In section 2.2, we're looking at solution of linear systems, the Gauss-Jordan, and I'm going to show you how to use your TI-83 or 84 calculator in order to solve this problem, and it'll help save you a little time. So first of all, we see the problem, the Gauss-Jordan, and we have three different linear equations to solve, a system of equations here. So what I need to do first, I need to put them in correct order as far as we want our x's, y's, z's, and our constants. Then we're going to write an augmented matrix, which you see I've already done, where I've taken the coefficients of each equation and put them into my augmented matrix. Now at this time, we're going to use the TI-84, where I have a TI-84 here. And let me go ahead and bring this back up, and we need to remember what our matrix is at this time. So using your, this is a TI-84, but a TI-8384 works very similar. The first thing we're going to do, we're going to go to where we have the matrix, so we're going to go second matrix, and that brings up our matrix information. We're going to scroll over to edit, enter, and the size of our matrix was a 3 by 4, a 3. Remember, it's rows by columns. We had 3 rows and 4 columns, and now it will give us our matrix where we can add our values in. And I'm going to do the first row, -1, 1, enter, 0, enter, -5, enter. Second row, 0, 1, -1, 3. And then the last row was 1, 0, 1, 0. So you can kind of check your matrix. You want to make sure you have your values correct. Oh, I think I missed one. That should be a 1. 1. That's always, well, it's always good to double check. -5, let's see. Let's go back to our 1, 0, 1. Okay. And then the second row was 0, 1, -1, 3. And then the first row, and let's just check all those values, and I think we're good. So once you double check, make sure your values are correct. We're going to do second, quit, go back to the matrix, scroll over 1 to math, and then we're going to scroll up until we see the RREF, and then enter, and go back to matrix, and there's our matrix that we put in, A, enter, and I'm going to go ahead and close that parenthesis and enter, and there we get a reduced row echelon form matrix. Now, how does this help us? Well, remember that first column, that's your X column, the second column was the Y column, and the third column is the Z column. So since this is a nice reduced matrix, this tells me this is my 1Y equals -4, and then, I'm sorry, Z, my 1Z equals -4, and then my 1Y equals -1, and then that's a 1Z, or Z equals 4. So we know what our answers are now that we have used our calculator. Saves you some time from doing or reducing the matrix by hand. Not that that's not important, but your calculator can save you a little time. So we end up and we find out what our values are. There is a 1 solution, and that solution is, and let's type that in as 4, -1, and -4. So we have, there's my X 4, my Y is -1, and my Z is -4. So that is a 1 solution. And always remember your systems of linear equations, they'll have either a 1 solution, just like we found for this one. You may have infinitely many solutions, and that's depending on how many variables we have. We may have to use a parameter, and I'll do an example like that. Or you may have one that's a no solution. And again, we'll have to look at what does that look like as a matrix. So hopefully this has helped. And if you have any questions, please feel free to ask.